Hey chemistry students, this is Mr. Resentes. I'm on page 56. This is chapter 2. We're still in unit 1, and this chapter we're going to talk about energy. Alright, energy is hard to define because it comes in different forms. The only way we could possibly define energy is, if we had to define it, is it's the ability to do work. That's what energy is. But really when we talk about energy, we talk about the different types. And here are a couple of different types of energy. Kinetic. And kinetic energy is the energy of motion. For which thermo energy is an example. Thermal energy is an example because thermal energy is a type of kinetic energy because temperature is a measure of particle movement. So temperature is a measure of particle movement. The faster the particles are moving, the hotter it is. Absolute zero is, in Kelvin scale, is no movement whatsoever. So another type of energy is potential energy, and potential energy is stored energy. For which gasoline in your car is an example, food in your fridge is an example, and this includes electrical potential energy. And we don't call it electrical potential energy. What we would call it is a battery. I'm talking about batteries, of course. Alright, so batteries are an example of stored or potential energy. The unit of energy is called the calorie. And a kilocalorie, of course, is 1,000 calories. That's what we use when we're talking about food. But in the lab, we'll usually we'll just be talking about a calorie. Kilocalories with a capital C. But 1 calorie, not kilo, but just 1 calorie, is the heat needed to raise the temperature of 1 gram of water 1 degree Celsius. That's a definition of the calorie. It's the heat needed to raise the temperature of 1 gram of water 1 degree Celsius. So 1 calorie equals 1 gram times 1 degree Celsius. The SI units for calorie are joules. So 1 calorie equals 4,180, no, in 1 point, excuse me, 1.4, I'm sorry, 4.184 joules. I don't know what I was thinking. 4.184 joules. All right. Not 4,000. I don't know what I was thinking. My apologies. beg your forgiveness. Okay. The law of conservation of energy, it means that it's going to be not lost or given up. It's only going to be transferred. The law of conservation of energy means basically that energy is neither created or destroyed. It's only transferred. It's only transferred. All right? So if we had, perhaps an example might be a balloon with loads and loads and loads of potential energy, but it has very little kinetic energy because it's not moving. Then you let that balloon go and it starts to deflate. Then you have very little potential energy, but then you have loads of kinetic energy. So the potential energy transferred to the kinetic energy once the balloon is released. All right. Another temperature scale is the Kelvin. You don't mention degrees when you mention Kelvin. We'll use the Kelvin temperature scale in SI units as well. And to convert Kelvin to Celsius, you just subtract 273. Alright? And then to convert Celsius to Kelvin, add 273. Alright? So 50K is equal to, 50K is equal to how many Celsius? Question mark Celsius. And Celsius you do in degrees. So because we're going from Kelvin to Celsius in this situation, what we would do, of course, is we would subtract. So 223. Negative 223 C. All right. Now, by the way, not only is energy neither created nor destroyed, it's important to note that matter can neither be created nor destroyed. Only transferred. Alright, so matter and energy can follow the laws of conservation, that you cannot create them, you can only, or destroy them, you can only transfer them.